Hello guys, welcome back. So in this lecture, let's quickly implement the push method for the doubly linked list. Okay, so it's gonna be straightforward only. So let me quickly explain you what we are going to do is, see, if there is no length in the linked list, let's say our linked list data structure is empty. Okay, and then if we are pushing something, then it should be the first node. It should be the head and tail both, right? Head and tail, right? So if it is a first node, right, but if there is already some node in the linked list, let's say node 1, and then let's say we have node 2. Okay, so right now in this case, since it is a doubly linked list, okay, so we'll take it like this. Okay, I think it's zoomed enough only, right? Yeah. So right now this is going to be the head node and this is going to be the tail node. Okay, now if you want to push something in it, okay, so what we have to do is we simply have to take the tail node from here. Okay, we are not going to do anything with it. Let me show you what we will be doing. Okay, so let's say here we have node 3 as a third node which we are pushing. Okay, push, right? So what we have to do is this node dot next we have to attach the new node which we are pushing. Okay, and then we will update this node as a new tail, right? And this is how we have actually done in the singly linked list. But now since it is a doubly linked list, so what we have to do is we have to track the previous node as well. So for that, what we have to do is we simply have to update the this node dot previous. Okay, so that these two nodes get connected. Okay, because we have the next as well as previous. If we are updating the next this node dot next as this node, then we have to update this node dot previous as this node. So if this node have idea like which is the next node attached to it, this also should have idea like which is the previous node attached to it. Okay, so there is nothing much complicated. Let's quickly implement it. Okay, so let me name it as push. Okay, so here obviously we'll need some value and then const new node equals to new node, and here we will be passing the value. Okay, now here since it is an empty list, right, so this time I'll use this thing. Okay, if there is no length, right, so in this case what we have to do is we simply have to set this dot head equals to new node, and same we will be doing with this dot tail equals to new node, and then what we have to do, this thing, this dot length plus plus, right? So we are simply incrementing the length after pushing anything. Okay, now if there is already an existing node, so in that case what we have to do, we simply have to take that tail. Okay, and then we simply have to attach the new node as a next value of our current tail. Okay, so this is the new value, this I am going to attach as a next value of our current tail, right? And then what I will do, new node dot previous I am going to update as the this dot tail. Okay, so if we are attaching the new node as a next node for the current tail, we have to store the current tail as a previous node of our new node, right? So this is what I have explained here. So right now with this line what we have done is we have simply attached this node dot next as the new node. Okay, so this node have idea which is the next node, but right now this node doesn't have the idea which is the previous node. Okay, so to make that connection only we have stored the new node's previous as this current tail. Okay, and then what we have to do is this dot tail equals to new node. Okay, that means we are simply updating the tail. Okay, And we are done with our logic for the push method implementation for the doubly linked list. Okay, so let's quickly test it whether it is working fine or not. We already have DLL here. That's actually nice. So new node. Okay, here I'll be using new doubly linked list instead of new SLL. Okay, and here I won't pass anything. Okay, so now let's see what happens if we push anything in that, but in this particular thing, right? So I will be using it like this. Just give me a second, guys. Let me reach that place. Okay, so here don't use allow controls, understand, please allow pasting. Okay, just give me a second, guys, because it is okay. I have to use backticks or what? Okay, I have to clear it like this now. Okay, now I can paste it, right? So now as you can see, if I expand it, our doubly linked list is empty right now and the length is 0, right? Now if I use dot push in it and if I pass some value, let's say 1, okay, then let's see what happens. Okay, and there is one thing which I have actually missed, is to return the linked list at the end. Okay, so since we are updating everything, we are if there is no node, then we are setting the head node tail node. If there is a node, then we are updating the new tail. So at the end we have to return the linked list which we have created. RETURN, I think I have wrote it in the correct place only. No, it's not the correct place, it should be here. Okay, so yeah, now this way we will get to know like what is the current value, latest value of the linked list, right? This one actually I forgot. Yeah, now if I push it, so before that let's quickly see our doubly linked list is empty only. If I push something in it, let's see what happens. Let's say 1. So now node is 1, tail is 1, length is 1, head node is this. Okay, tail node is this which have some value, and then what was that, length is 1. Okay, now if I push something else, push instead of 1, let's push 2. Okay, now the length is 2. Let's see, head node is this. Okay, next node is some node here, and then tail node is 2, right? And then the previous node of the tail node is 1. Okay, as you can see, head node dot next is 2, and then its previous is obviously null only, because before head we don't have anything and after tail we don't have anything. That's why previous and previous for this one is null, next for this one is null, tail is null, right? So now at least we can see whether it is like it is properly forming, right? So now let's quickly push few other values, 3, 4. Okay, so we have linked list of 4 nodes, head is 1, tail is 4. Okay, if we expand head, head dot next is 2, head dot next is 3, head dot next is 4. Okay, that means 1 2 3 4, it is getting stored in sequence only. So previous is 2 for this third node. Okay, if you check the previous of the fourth node, that is the last node, the previous value is 3. Okay, now if you expand this, the previous value is 2, and then previous value is 1. That means we are keeping backtracking the nodes as well. Okay, and this is what the push method of the doubly linked list looks like. So we establish a connection in both the directions. Okay, so yeah, this is it for today. See you in the next one.